Welcome back to our geometry series. Today we are up to section 8.2 where we'll be looking at pyramids. In previous sections we looked at a polyhedron. A polyhedron is a geometric figure made up of a finite number of polygons called the faces. The common polygon sides are called edges, and the common points are called the vertices. Let's take a look at this polyhedron. It's a polyhedron where all the faces except one have a vertex in common, as you can see here. When we have a polyhedron like this, where all the faces except one have a vertex in common, this is called a pyramid. The face that does not contain the vertex is called the base, shown in red here. The other faces are called the lateral faces. And here I've only highlighted one, but you can imagine that there are 4 lateral faces on this pyramid. Lateral faces are joined by lateral edges, and the edges of the base are called base edges. If the base of a pyramid is a regular polygon and its lateral edges are congruent, then it is a regular pyramid. So for example, if this is a square, the pyramid is a regular pyramid. If this shape down here is a rectangle, then the pyramid is not regular. The height, lowercase h, of a pyramid is the distance from the vertex to the base. For a regular pyramid, this is also the altitude. Next, let's think about the closest distance from the vertex to a base edge. If you want to, you can imagine that it goes down one of the lateral faces like this. This is called the slant height, usually depicted with a lowercase l. And that leads us to theorem 92. The lateral area of a regular pyramid equals 1/2 the product of the slant height and the perimeter of the base. So in this case, we're adding up the total area of the lateral faces. So lateral area equals 1/2 lowercase l times p, the perimeter. So for this example, we'll say we have a regular pyramid with side 7 and a slant height of 10. Since it is a regular pyramid, we know that all 4 sides of the base have to be the same, so we know that all 4 sides are 7. And that gives us a pretty easy perimeter of 28. We already know that the slant height is 10, so we can plug these into the equation. 1/2 times 10 times 28 equals 140. This is the lateral area of this regular pyramid. Next, let's look at theorem 98. The total area, T, of a regular pyramid equals the lateral area, L, which we just looked at, plus the area of the base, B, or T equals L plus B. So we're adding up all of the areas of all the faces of the pyramid. But what is the area of this pyramid, or B? Remember, we have a regular pyramid, so the base of this pyramid is a regular polygon, or in this case, a square. And we've shown that there's a right angle here, which tells us that it is a square. So for the area of the square, we just multiply the 2 sides together. So we know that the area of the base is 49. And the total area would be the lateral area plus the base area, or 140 plus 49, or 189. That is the total area of this regular pyramid. Next, we're going to look at volume. Remember, volume is like 3-dimensional area, or you can think how much water would fit inside this pyramid if you tried to fill it up. And that leads to theorem 94. The volume of a pyramid is 1/3 the product of its height and the area of its base. So V equals 1/3 B times H, base times height. So again, we have another regular pyramid with side 6 and a slant height of 5. So the volume equals 1/3 the base area times its height. What's the base area of this regular pyramid? Again, we have a square as the base, so we just take the side and square it, 6 times 6. The base area is 36. What about the height of this regular pyramid? Now your brain and your eyeballs probably look right at this 5 that we've been given and thinking, hey, that's the height. But it's a trap. Remember, 5 here is the slant height. not the actual height. This is the height that we need. This is the h in the formula. This is the true height of the pyramid. But fortunately, we have a regular pyramid, so this is pretty easy to find. Because we have a regular pyramid, this height is centered about the base of the pyramid. Think about this distance here in orange. How far is it from the edge to the middle of the base? In this case, it would be 3. It's halfway across the square. We know the square is 6 across, so halfway across would be 3. If it's easier, you can look at the triangle all by itself. We know we have a right triangle with one side 3 and a hypotenuse of 5. And here's where our good friend Pythagoras comes in handy. We can use the Pythagorean theorem to find that the height, or the side of this triangle, is 4. So now we know that the height is 4, we can plug that back into the original equation. Volume equals 1/3 base area times height. So 1/3 times 36 times 4 equals 48. That is the volume of this pyramid. Let's jump over to the whiteboard and do some examples. Ooh, look at the little pyramid. It's so tiny. I can't pick it up. Okay, time to try to draw three-dimensional things on a two-dimensional surface. That is already not a straight line. And we're going to go like this and like this. So here's our pyramid. And then we'll draw this edge back here and this edge back here. And we're missing this one here. So we're going to say that we have a regular pyramid and all the things that come along with that. So since we have 4 sides of a regular pyramid, we know that the base has to be a square. So we know this is a right angle and this is a right angle. We got 4 right angles along the base. Let's say that each side of this pyramid is 10. That's a nice number. And then what we're going to do is maybe a line here. This is the slant height. We're going to say that this is 15. And again, this would be a right angle as well. We want to find the lateral area and the total area. We know the lateral area is 1/2 the slant height times the perimeter. And this is theorem 92. And we know that from 93 to the total area is the lateral area plus the base area. So let's start with this one. The lateral area is 1/2 the slant height times the perimeter. So we'll just rewrite this as 1/2 the slant height, which we've been given, is 15, times the perimeter. All right, so if we have a square and the perimeter, and one side is 10, the perimeter would be 40. Now let's just say this is inches. Let's put some units on here. This is also inches. So what is the lateral area? So if we multiply all this together, we get 300. But since we have units, we know this would be square inches. Again, the lateral area would be the area of the 4 sides of this pyramid, not counting the base. So just these 4 triangles that make up the 4 lateral faces. So for total area, we take this lateral area that we found and add the base. So lateral area we know is 300. And now the base. Well, the base is a square, and one side is 10. So the area of the base would be this side squared. And let's write that out. Plus 10 squared, which is also known as 100. So this would be 400 square inches. All right, I'm going to try to draw a regular pyramid whose base is a hexagon. Let's see how well this goes. So here's kind of the face closest to us. Here's another lateral face. And then here's a edge on the back. Here's kind of the back wall. Here's another edge. Here's a lateral edge. And here's another lateral edge. So we've got a regular pyramid again, but this time the base is a hexagon. And let's say the side is 6. And we're going to draw a slant height. Let's do it right on this front face so it's a little easier to see. the slant height, I'll put this here so we can see it, is 12. It's this thing. That's very hard to tell. So we'll just put it over here that the slant height, L, is 12. That's a little easier to read than whatever this is down here. So what is the lateral area? Well, we know that is 1/2 the slant height times the perimeter. Well, slant height we've been given, that's 12. But what's the perimeter? We have a regular hexagon with side 6. So 6 sides, each 6 long. The perimeter would be 36. So this would be 216. What about the total area? Well, again, total area is the lateral area plus the base area. We already know the lateral area. We just found that as 216. What about the base area? What's the area of this hexagon? What we're going to do is, see if I can draw this down here. Let's just think about a hexagon for a second. Here's our hexagon, and each side is 6. We're trying to find the area of this polygon now. Well, if we have a regular hexagon, it's made up of 6 regular triangles. Think of it like a weird pizza, right? So here's a triangle, it's 6 triangles, and each triangle has 6 on its side. It's a regular triangle. So one of them would look like this. So we can find the area of this triangle. We can just multiply it by 6 to get the area of the base. So what's the area of this triangle? Well, the area of this triangle is 1/2 base times height. The base is 6, so 1/2 base times height. What is this height? Well, remember, we have a root 3, we have a 30, 60, 90 triangle here. But there is a little shortcut we can do. So let's erase some of this. The area of a regular triangle is just equal to root 3 over 4 times the side squared. So we have root 3 over 4 times 36, which is 9 root 3. That's the area of this triangle. So I need to multiply this times 6. So this is just one triangle. And the area of the entire bottom would be 6 times this. So 6 times 9 is 54. So the area of the base area would be 54 times the square root of 3. Now we can leave it like this because we've got this radical here. But if you wanted to, you could plug this into a calculator. And this is about 309.53. It's approximately 309.53. And that would be the total area of the 6 lateral faces plus the base. So this is the lateral area, the base area, and the total area. All right, let's clean this off and do one more example. All right, let's see how well I can draw this one. Okay, so we have a pyramid whose base is an isosceles triangle. So we're going to say that this is 7 here, from here to here, and this base of this isosceles triangle is 6, and the height of the pyramid is 15. So if you can imagine, from this dotted line to here, we have a right angle. So we've got an isosceles triangle down here, whose base is 6 and whose height is 7, and the height of the pyramid is 15. And all we want to do is find the volume of this pyramid. Remember, from our theorem 94, let's put it down here, the volume is equal to 1/3 the base area, big B, times the height. Okay, so first let's find the base area. What is the area of this triangle? Well, the base area, the area of this triangle, is 1/2 little b times h. And little b is the base of this triangle, and this h is the height of this triangle. So we've got a couple of little h's here. Let's be careful. So we're only talking about this little triangle down here. So 1/2 the base of this triangle is 6 times the height of this triangle is 7. This equals 21. 1/2, 3, 20. Yep. So that's this B, the base area of the pyramid, is 21. Let's just write that down. Volume equals 1/3 base area, 21, times this height, the height of the pyramid, not the height of this base triangle. So the height of the pyramid is 15. So if we do all the math on that, we end up with 105. And let's give this thing some units. Let's say this is meters, and these are all meters. So this would be cubic meters. It's the volume. It's how much space is inside this pyramid. And that's it for today. We'll see you next time.